Alright, hello and welcome. This is the Tank Buddy video. I don't know what else to call it. I don't have a good title, but the Tank Buddy is what it's going to be called. I think that's kind of funny. So if you ever got into electroplating, electroforming with copper sulfate, and you wanted to, let's say, gauge all your tanks with pH, so you can keep track of your pH levels in all your tanks, and keep track of all the temperatures in all your tanks. This is a scalable module way of doing that, and I'm going to show you the build. It doesn't take too much, but it does take some skill in home automation. Not too bad. I have an entire series about ESP Home and Home Assistant, and this will be a part of my Home Assistant. So home automation allows you to gauge all your house. You can keep track of your air quality, different CO2 levels, radion levels, and everything else. So why not have a total flex and have my electroforming tanks all hooked up to pH meters, right? And then have them on a interface on my computer. Yeah, right? It's ridiculous, but that's what I do. I do really ridiculous things. Alright, so basically what it comes down to, you have a pH meter that's highly undocumented, and it came from China, and it came with no instructions whatsoever, and everywhere you go online, absolutely no help. So I had to decrypt that thing and then write code for it in YAML, a very interesting language in ESP Home. So once you have that, you have the schematic and you have that code together, you now have the ability to gauge pH in your tanks. Underneath it all, there's a thermistor. So the thermistor sits in your tank. It's coated with a polyvinyl, so it can be acid proof. It can sit in your tank and take in readings. So let me also show you the schematic. I share with you all this in the video too, but just to give you a heads up of what you're getting into. Okay, you have an ESP32 microcontroller. It's hooked up to this pH meter. Okay, it's only got 3 useful pins on it. The other ones are not too useful. One is to calibrate it. The other one's temperature, but it's really bad. So I just have power, ground, and then PO is your pH. Unfortunately, the pH, this sensor is a 5-volt sensor, and this ESP32 is a 3-volt sensor. So I had to build a voltage divider. That's what this is. And that will knock it down to 3 volts so that this thing can read it. And what's really good about this series is if you know how to do this, you can build a sensor for absolutely anything using ADC. So you can gauge like wind, temperature, whatever, using the same type of coding. So I walk you through how I'm basically building this sensor from nothing. So if you have that underneath your belt, you can do that also. Okay, another thing is a thermistor. Okay, so a thermistor this is an NTC. This code is already built into ESP Home, which is quite nice. It does need calibrated because this is an unknown thermistor that I'm sharing with you, and that will allow you to learn how to calibrate an unknown NTC thermistor. Which is also a very useful skill to own in some parts of the world. This is also a voltage divider, so it will take and have a very large variation of change for this thermistor, so it can read like negative 50 degrees all the way to probably 200 or something like that. But it does have an unrealistic variance of temperature that it can read. I don't even need that much. Most of my tanks stay within like 60 to 80 degrees, but this thing will handle it. Alright, and that's it. I mean, there's only 2 little wires here, and I walk you through the rest of this, but not too many parts. I think the whole build altogether was probably 50 bucks worth of parts altogether from Alibaba or AliExpress, and you too can make a tank buddy. And you can add as many thermistors as you wanted. You just have to keep tiling this over as many times as you want, and you can add as many of these as you want, but you are limited, I think, to 5 pins. So at some point you might have to make 2 tank buddies if you have a lot of tanks. Okay, cool. So that's the schematic. I think that's it. That's all I want to say at the very beginning of this video. That's what you're getting into. Alright, so here is the tank buddy in action. Right now, this basement is 58 degrees Fahrenheit. Okay? Tank buddy just hangs there on the wall, chills out. He's got a probe in my electroforming tank. You can see the blue one. And to the left of that is this wire that goes down in there. That is the thermistor. And then I have a thermistor in this tank also. I'm still waiting for my probes for the other 3 tanks. Now that I got it all hooked up, I am definitely ordering the other 3. So yeah, he just hangs there. Now he's got enough room in there for the other 3 probes too when I can get them installed. So if I want to see what they are, just go on my app here. So this is Home Assistant, and boom. The tank on my right is 77 degrees Fahrenheit, and the one on my left over here is 60. So that's telling me that I should probably use this tank right now, and then double up my fish aquarium heaters on this one because it's so cold down here. So pretty cool, right? I got the data, I know what's going on, I know not to add any acid to that tank, and it's kind of cool to have that on my phone along with all kinds of crazy data that's down here. Alright, so I just wanted to kind of show you what it looked like in action. I know it doesn't look like it's doing much, but it's pretty fun to have. Alright, so this is the first portion of the build where I show you my power supply. My power supply is an AC to DC power supply. You can pick these up at your local gas station. They are these things. You just tear them apart. See? This is 5 volt 2.1 amp. Just took it apart. They come with 2 little prongs on the side. That's where these 2 little prongs used to be. Okay, those little 2 prongs usually slide into these little brackets. And this is just an extension cord, and it's really long. There's no such thing as a polarity on these where you have to worry about the left or right. It's just a little baby switching power supply. So on the green board, it's labeled positive and negative, and what I did is I just soldered these headers to it. So I'll share with the link with the headers below. This I got at the gas station. They're about $4. There was a video I posted before that showed you how to make a multi-sensor for your Home Assistant. That one had a $20 one in it, and this one runs just as well for $4. So I don't know. And it's smaller. I need really small because I got a lot of stuff I got to put in here. So that's my first one I put in here. I put it in through the side like that. I use a zip tie right there so you can't pull it out. And then these are soldered to the posts, and this is soldered in here. This is just hot melt glue, and I also put some hot melt glue there to make it extra secure. And that's my very first part inside this giant case. I got many more, and I'll share with you each one as I mount it. Alright, so the next part is an insulator. So what you would do, I love microscope glass. It's a joke even in some forums. about microscope glass and my exploits of microscope glass. So this is microscope glass. It's sitting on top of the transformer, and then it's just tacked on right here. So the reason for that is then I can insert this. So this is what I shared with you in one of the other videos, but this is just the ESP32 chip soldered to green board, or Perfboard is what it's called. And then if you look, these are the, let's see if I can zoom in. So these right here are my grounds. So ground, 5 volts, more grounds, 3 volts. So not sure yet what these are going to be running off of, but this is my standard build for every one of these things, is just this perf board with these headers put in and these extras put in. Usually if I just build this, I can build just about anything using this. So here's what it looks like on the other side. You can see how they're just all connected for the 5 volt 3 volts, 5 volt 3 volts, and then all the headers are just soldered. Okay, so that's a pretty standard build. You can, and if you're just getting into this chip and understanding how cool it is, this is a good even development board setup for you. It's almost better than having it on breadboard, to be honest with you, because it doesn't fit quite well on breadboard. You'll find that out. So, you know, like this, for example, these two, the coming off that, hook up to my 5 volt and my ground. So now I can connect those up. So you can see where it says VIN on this chip. I'll put a link where this chip is again, and ground. That's where those two come off and then hook up to that. And then this is going to get hot melt glued in there. So I have 4 electroforming tanks. Right now I have to develop the code for just one of these to work, but that's why I'm keeping all this extra space out here, is because I might want to have 4 of these in line all hooked up. I don't know why I would do that, but it sounds like something I would do. So now I have enough room for one above it, one here and one right here, and I'm pretty sure the ESP32 has enough inputs to be able to handle it yet. So I'm still trying. I haven't even started with what type of signal this is. Is it analog? Is it UART? Is it binary? I don't know yet. So, but I do know I'm ready for anything. Alright, now I must be complete nerd. Okay, ready? So this pH meter right here uses a voltage between 0 and 5 volts. Okay? 0 will represent 0 pH. 5 volts represents 14 pH. Okay, that's how. Now what we need to do is set the mid value between that. And a way to do that is we have to calibrate the pH meter so that 2.5 volt is the mid range between 0 and 5 volt. Now you would think that'd be already set, right? But no, it's not. And then that's what so all these pH meters are, I guess, completely off, and what we do is we calibrate it first to have that range. The reason we do that is because when we go to read it using a microcontroller, we do not want it to dip into the negatives. Okay, so, and it will if we go to plunge it into acid. Okay, so because it could be already set with a mid value that's not 2.5 volt. Maybe it's 3 volts, so that would put it to -1 when it hits acid. Okay, if you're confused yet, it's okay. I got you. Got you. Alright, so now this power supply, as I pointed out earlier, okay, this one right here, boom, has a positive and negative on it. And so does the pH meter. If we zoom in on the pH meter, it has right here a G standing for ground, and this one the positive voltage. So we're going to hook it directly to that power supply, not the microcontroller. I repeat, not the microcontroller. So how you do that is you hook, here's your positive, and it's actually being ran all the way over there. So these are females, right? These are female headers. Okay, female, female. So this is my positive and negative coming from that. And this is my positive and negative coming from that. Positive being white, brown being negative. Okay, I ran out of colors on my headers, sorry. So what you have to do is you have to run positive ones or males over to them. So just know that this white wire is being ran all the way over to here, and the black wire is being ran all the way over here. That's your first connection. How you get it over there is just you and your variation of header wires to get over there. I would suggest not running out of colors like I did, and it would be less confusing. Okay, sweet. So now that we've established the power to it, so from here to here, it gets a little less confusing, but not too much. We have this green, okay, this stands for the second ground. The second ground is being used on a multimeter, okay. So over here I have my multimeter, boom, it's the one I recommended that you buy in my electronics course, and it's being fed onto the terminal or the probe of the multimeter. Now if you're totally nerdy, you have the very, very sharp probe that you can do cool things like that. Ooh. Alright, sweet. Now, there is a probe calibration pin. That one is called DO. I'll zoom in so you can see DO. There's DO. See it? So DO is being hooked up to my positive on my multimeter. Okay. Alright, what's the other wires go to? Nothing right now. Alright. Now, on the BNC, you can see that there is a center pin. Okay? The center pin, what you need to do is run a ground or run a loop to it. So here's how you do that. You could do it this way, where you take an alligator clip and connect it to this, and then this goes into the center. I'm looking at my, so you could do it that way. How do you know that's working? Well, it's very simple. If you look at your multimeter, it's fluctuating a little bit, but also there's this little red LED on there, and the little LED red is fluctuating also, indicating that you have a good connection. If I try to, let's say, put it in there and put a little pressure on it, it gets a little bit better. So with one hand, what I would do is just hold that wire like that so that it's got a good connection. With your other hand, you must take a screwdriver, okay, and put it on this screw right here and turn it until it reaches 2.5 volts. Now let me tell you, it's sensitive, okay? So you're never going to get it at a true 2.5 volt. You're going to get close though, and you can see like 1/1000th of a turn turns it to like, yeah, all kinds of crazy. So how you know it works, you go like this, you rotate it this way, and it stops, it caps at 0.83. Okay, we know this is the beginning of the wormhole. Now we rotate it ever so slightly. Ever so slightly. Until it starts going crazy again. Oh, you see it? It went. And there we go. Boom, way up there. So we overshot. Oh. Now I'm going to let off of the screw because I constitute as a ground. And that's really close right there. So on average it's going to 2.5 pretty well in that. Okay, so that's how you calibrate the pH meter that way. It's now calibrated, good to go. You can unplug all your leads. You can unplug it from the power supply and everything else. So all these wires will run to it, but they're not technically hooked up to anything just yet. That was just the calibration phase. We must move on. But not right now, because I need a drink. Alright, so this is probably by far the coolest project I've ever taken on. It's very interesting because one thing, it's a little outside of my things that I usually play with. So there's a lot of math. There's some math on this one. You don't have to do any math. I'm doing all the math for you, but some of the fun things that you have to kind of look at is the fact that the microcontroller that I'm using only actually reads 0 to 3 volts, 3.3, somewhere around there. And then this sensor is actually a 0 and 5 volt sensor. So we have to have a very creative way to break this 5 volts down to a 3 volt range in order to be read correctly by the microcontroller. Okay, again, you don't have to do any of this, but it is fun to flex. You do have to do some soldering. It's not that bad. So what we do here is I'll try to draw this out for you so you understand what's going on. So here's your ground. Okay, and what we're going to do is do one of these. This is our resistor. So this is a 1K resistor, another 1K resistor, and yeah, we could do it one more time. And then right here, this is going to represent my power. Okay, so what we do here is on the sensor itself, and this is a 1K sensor too, we are going to take this, we'll plug the sensor wire into this end of the voltage divider. So this is a voltage divider, and we leave this ground from the multi controller, and then right here, this is going to then plug into my microcontroller on pin 36. So pin 36 or A0 is now going to be able to read the 5 volt, because the 5 volt is now being taken down to a 3 volt range. So now 0 to 3 volts equals a pH of 0 to 14 pH. Pretty cool, right? So it used to be 0 to 5 volt equals 0 to 14 pH. Now, if you were using like an Arduino, you could still use the calculation here and leave off the voltage divider. But since I'm using this for ESP Home and Home Assistant, I'm going to be using this one for the ESP32. Okay, so again, if you don't know anything about voltage dividers and everything else, that's cool. But if you do, that's the plan. All right, so what's that look like? All right, easy peasy. Yeah, I'm pretty comfortable with like just destroying this. Okay. All right, so here's my ground. Okay. And this is running from this. So here's my ground, and it's running all these pins. 1, 2, 3, 4. Okay. One of the pins, the very last one, I just decided to take this out, and then these are soldered together right here. On the back side, you'll see that. So boom, boom, boom. So this is soldered together. And this soldered together. Okay, so now I have two headers here. You only need one header, but if you know with soldering headers, you usually solder two because one's a pain in the butt to get in there. By the time you hold it and then flip it over, the thing falls out half the time. So we got a double header here just for fun. And now the purple wire right here, labeled PO in here, this is my output pH. PO, output pH. Okay, and my ground, indicated by this ground and this ground, either or works. I use this ground. That ground is grounded here. My brown wire. So the PO gets hooked to here. Alright, sweet. So there's my negative, there's my positive, And now the voltage divider right here, this is what gets hooked up to my microcontroller. So to do that, you could just solder it, or in this case what I did is a jumper wire for you so you can get a better representation of what's going on. In this case, it's being hooked up to A0, which is the second pin on the microcontroller. If you bought the microcontroller that I specify in the show notes below, that's A0. Sorry, I live in Michigan. It's cold here. You don't know. It's getting cold. We have like an Arctic storm. Sweet. Alright, so these are buffer solutions. Okay, buffer powder. You can buy these on Amazon, and what happens is you can use them to make a known solution for pH. Now you can also use baking soda. Baking soda is a good one. It's got a pH of 8. But you need 2 reference points, 2 vectors. So you can, here's the most ideal situation that you probably want to do is buy these. They're cheap, they're on Amazon, and you probably want to mix all 3 of them using 250 milliliters of water, of distilled water, and I use these like little baby frat boy cups. So like that. So you can see at the bottom of this one is baking soda. It's got a pH of 8. And then I have another one over here that's the 6.86. So the bare minimum is 2. 6.86 is nice because it's kind of like the midpoint of the 14. So if you go to pH 0 to 14, you got 6.86 is the almost not dead center, but pretty dead center to it. And then you can use that to pretty much know that your calibration's on and that your voltage is correct. So I would definitely recommend the 6.86. But more so, I would probably just mix all 3 of these, and I'll show you how to type them all 3 in there as a calibration point. Okay, so I'm going to share with you a link. This link will grow as we grow together. Right now I'm only giving you this little snippet, but this will keep going as this video series goes. So the first sensor that we're going to look at is the pH sensor. And here's the code I wrote for it. The thing that we have to do first is calibrate it. And if you go down here below, what we're going to do is first comment out these. So we're going to use a number symbol for commenting. Okay, so all we do is to put a comment there. I'll have it commented out already for you. If you go to make a copy, you can make a copy of this Tank Buddy, and then that way you can edit it. Okay, so basically what we're going to do is take this code, copy it. We're going to go into Home Assistant. Again, if you haven't watched the multi-sensor video that I made, deep water. I could do this at least for you. Is new, continue, the name of the sensor you want, so I'm going to type in something fictitious here, and this is the one you want to take, ESP32. And then you can install this or skip it. I'm probably going to skip it. So that's how you make a new sensor. Now, I want to delete that actually, because here's mine. So I'm going to edit this. I'm probably going to share a little bit of this. I'm going to make sure I page down on it, so you might see me blank some of the passwords and stuff out. Okay, so right here is the bit of code that I have in. I pasted in. Ignore the stuff below. I'll go into that. So you don't really technically need this yet. So I'm going to make these commented out, just like I said. And then I'm going to save it. And with the ESP32 plugged into the back of the either Odroid or Raspberry Pi, depending upon what you use to install Home Assistant, I generally attach it right to the server itself for the initial installs, and then I can do it wirelessly after that. Okay, so install. So it says plugged into the computer running ESP home dashboard. So that's your Odroid or your Raspberry Pi. This will not show up if it's not hooked up correctly. Again, this is what it looks like if you're brand new to this, which you're probably not if you're watching this video. So it's plugged in here, and that's plugged into the Odroid. Alright, run that code. So you should already have 3, if not 2, hooked up. I will fake this out because I already got mine calibrated and I already got my calculations, but I'll show you how to do one of them. They all work the same way, and then you could just, do it as many times you want. You can even do it 6 or 8 times depending if you have other known solutions and have a super calibrated one, but I don't think that's needed. Okay, so this is what we do. We get some paper and a pen. And I'm going to switch over to .cam. Alright, so the probe is like this. You can see I have the plastic part off. It comes with a plastic part like this. You take that off. Okay, this is also a known solution that it comes with, but it's from China and I don't trust it, so yeah. I don't know how long that's been sitting on the shelf, to be honest with you. So you take it out and you put it in the cup. In this case, I'm putting it in the 6.86 one. Okay. So now it's in 6.86. What is it reading? Alright, lots of numbers. Don't get confused. It's okay. What we're looking for is the pH value of this. Okay, so the pH is right here. And what I want to do is make sure I got all these things hooked up correctly. Boom, boom. Before I start judging this thing. Yeah, that's what I thought. So the purple wire was a little loose. Okay, sweet. So 2.48 is what I'm reading. Okay, 2.48. So you write down 2.48, and then you write down your known buffer, which is 6.86. Easy, right? Okay, so now you do that again. This time I got, in this case, baking soda, super saturated in water. Okay, and I know that to be a value of 8. So right now it's at 2.16. And that's going to be an 8.0. Cool. And you repeat that over and over. You can read out all of them. You write down what it's reading, and then you write down the known buffer. Okay, so once you get all this information, then you close all this out, and then you uncomment this, and you write down those in here. Make sure your naming convention is spaced out like this, so these dashes go directly underneath the C. If they are offset like this, you'll see that this is going to have an error somewhere. Well, usually, but it will. So, there it was. It was up there. You'll see this little red dash thing. It's kind of like a caret, I think they call it, or tilde. So if you see this little tilde, you know that you got bad spacing. All right, so 2.42, it read out to be 6.86. In my case, it was 2.48, and then 2.1 went to 8.0. Okay, and I could do that for the other ones too. So that will calibrate it, and it'll tell it, okay, so this is the range it's going to be in, and now when I see a voltage of this, I know it's this, and if I see a voltage of this, and it's this. Now it's super smart. It's super smart. So 2 vector points will actually fix the entire string all the way to 14. But if you want to go and do the pH1 of 9.0, that would probably be smart too. I'll probably do that later, off camera. Cool. The rest of this stuff, I can briefly describe what it's doing or tell you. So this is your, this does not make it do any special math whatsoever. It just indicates it's pH, but it doesn't do any special math. Okay. The attenuation, however, is doing a special thing. So it allows the ESP32 to do a calculation between 0 and 3. So that has to be an auto in order for that to work. And then this median is taking 7 of the calculations and then doing the math on it, and it will pretty much average and then give you an abundant or a scope based upon those averages. So that's what median does. With this probe, you'll see that there's lots and lots of fake stuff, and you're going to need that. 7 was by far the best that I found, and then if you went a little lower than that, like 5, you're not going to get really good results. Okay. And here's your calibration point, and that's what I was telling you earlier. This is the pin it's coming on. ADC is just the analog to digital conversion, so volts over to a known data, or in this case a range of voltage over to a data point. And I think that's it. Cool. So save that out, install it. So you now should be able to take that probe and put it in one of the solutions that's 6.86, and it'll be about 6.86, and the other one will be about 8 if it's baking soda. Now it's going to range too, because pH is also dictated by the temperature of the solution. So if it's real high or real low, it changes the pH value of things, which is going to be really fun when it comes down to electroforming tanks, because electroforming tanks are at 80 degrees, 70 to 80 degrees. And in Michigan, I would say that's on the low side sometimes. So our other sensors are going to come into play when it comes down to it. I'm hoping that this has a really good temperature sensor on it. So that's what I'm calibrating right now in later parts of this video. Alright, so it's in the 6.86, so it's 6.64. And is roughly 37 degrees Fahrenheit. No. So that's the part I'm looking at right now. Alright, so now we're getting into temperature and how accurate we can get into temperature. So we're measuring the temperature of a liquid, okay, and we also have to measure it with a pH value because it's got acid in it. So we have to protect the thing that is being used to measure the liquid. Okay, this is called a thermistor. Okay, an NTC, thermistor. Okay, thermistor. Okay, and they look like this. There's a link below to this. Now, hopefully this holds up to the acid. It should. It's polyvinyl, so we'll have to see. Over a long time, it might break down. Who knows? At the release of this video, I will say that it's got a good chance of surviving. And it's got a bare minimum chance of contaminating the tank, other than just a little bit of zinc coating that might come off of that. But other than that, it should be good to go. So that's what the plan is, to use a thermistor to measure the temperature. Now this thing also has a temperature channel. It is very bad, okay? Not even close to the level of accuracy a thermistor does. So that's what I've been testing, is that I've deemed it not worthy, and we're going to move on to the thermistor. So in order to get the thermistor to work, it has to have a voltage divider on. We use 3.3 volts on one side of this voltage divider. It goes through a 5.6k ohm resistor, which you're going to have a 5.6k ohm resistor. The thermistor itself is a 10k, okay, but because the one I ordered doesn't have a B count on it, and a B count is basically a way of knowing the calibration ahead of time. It comes in a series of 4 numbers. Usually it's like 3095, but this thermistor doesn't have that, so we're going to learn how to calibrate a thermistor, which is pretty nerdy, right? Don't mention that you do it at a party and you're fine. So we're going to calibrate this little dude. This gets hooked up to the 35 pin on the ESP32, and this is ground, if you don't know a schematic. So power, ground, thermistor, pin 35. That might look all confusing, but it's really not that confusing. Okay, check this out. So I'm just going to take these off. I'm so used to hooking them up. So on our ESP32, we have this channel, the 3-volt channel. Okay, there is a resistor here, and one leg of the resistor is on these pins. Okay, so if you flip this over, you'll see that here is that leg of the resistor. It's going up and connecting to the 3-volt channel. Easy. The other end of this resistor is being hooked up to these two headers. Okay, so it just needs 2 headers, and you can see on the back, right here, it's just one solid glob of solder that connects all 3, the leg that's going in and these 2. Okay, so now what that does is I have my thermistor. It only has 2 wires to it. See, thermistor, and here's the 2 wires that come out of it, and we'll call one representing positive and one negative. And there's no polarity, so either one can be negative or positive. So I just did one of these. I got these header pins that go into this connector. If you wanted, you might want to see what kind of connector this is and get a Perfboard version of that, but I'm not picky. So what this is going to do is ground is the black wire. So that's going to get hooked up to the ground channel. Here's ground. Okay, ground. All these pins right here are ground. Okay, and one side's going to be hooked up to that header, just like that. So what's the other pin for? Well, that is for channel 35. So, boom. And then the other part of this gets hooked up to D35. So ignore this hot mess right here. This was all my testing stuff. The pH one is still valid. That's the pH channel. It's down in here. That's this channel. So that's still valid. But the rest of it is not needed at all. It was just me testing out the temperature sensor on that pH monitor. Alright, so now that we have that, okay, and it's kind of clearly shown, it's also going to be on the final schematic what is really needed in the long run. So I'm going to show that final schematic at the very beginning of this video so you're aware of what's going on and what parts you're going to need. But this is the temperature start. Now we got to do some calibration and calibrate the 10K thermistor so that it gets a really accurate reading. Alright, so we're going to need this bit of code right here for this thermistor. Okay, notice that there's an area that's commented out. That's the calibration settings. I'll show you how that works. Okay, so we're going to go over to ESP32 and I pasted that in. Okay, this is where I pasted it from, but that's pasted that. So I'm going to write this code. To my ESP32. I'm going to need 3 cups of water. Okay, one is going to be really hot water, one's going to be really cold water, and one's going to be room temperature water. Okay, so prepare yourself. Stop the video right here. Go get 3 glasses of water. You're also going to need one of these. Okay, it's going to be some kind of thermometer. This is the Taylor brand, and it doesn't really matter. You can go to your local grocery store and get one. This one sticks in a turkey's butt and it tells you the temperature, and it works out really well. Then let's see what else. I think that's it. Okay, a pencil and a paper. Okay, so I have right now room temperature water in a cup for my one example that I'm going to show you, and you have to repeat this the 3 times. Okay, if I did all three, it would be boring. Okay, so I have the thermistor in the liquid right now. Room temperature, it's at 65 degrees. Okay, notice right here I have this resistance value. Resistance is 13,419. So I have to write that down somewhere on a piece of paper that isn't got stuff on it. So I write 13,419 space 65 degrees, because that water is 65 degrees. Okay, cool. Now I go and dip the thermistor in cold water while this window is up. Okay, and while it's in cold water, I'm going to get a different resistance value, and I'm going to write down the temperature of the water that I measured using the thermometer, and then the hot water too. And they're going to be, all three of them are going to look like this. Okay, so what are you going to do with that magical piece of paper? You're going to put it into your long-term storage memories and go into edit. And then you're going to write those. This is ohm, by the way. That is not a zero. Okay, so you're going to write those numbers in. These are the numbers that I got, and I'm going to keep because they're really good. So once you put your numbers in, you can now uncomment by putting the cursor here and hitting delete. You should be able to delete these comments out and it do that. Okay, that means that everything is lined up. Here is a YAML crash course. These dashes line up, the P's all line up, and these dashes doing to this calibration have to line up with the C. Okay, and you look up here, it's the same kind of schema, but you're going to see that this is a little bit different over here. Don't get confused. It's YAML. It doesn't make sense. Never did. Okay, cool. All right. Now, once I write this, I will have now tank 1 temp therm. The reason I have that is thermistor. Okay, so that's my naming convention for all my tanks. I'm going to capitalize that one though. This one I am definitely not going to need. It's going to end up coming in for the ride, but I'm not going to use it for any kind of calculations. I don't have to add it to my front end if I don't want to. Alright, we're going to install this. See how fast I moved right through that? Yeah, because I didn't want to be boring. Okay, so I'm actually going to close this window and we're going to go over to the section under settings. We're going to go device and services, and we're going to go to the ESP home and go down to tanks multi. Again, if you have not had this, it's because you haven't watched my other home assistant videos where I set all of this good stuff up. So you have to watch those. So notice I have 11 entities here. I don't need all 11 entities. These were just things I made on this one. So I'll show you how to get rid of ones that you don't want. Okay, so for example, I got a few of these in here. And I love how you can never read the name here. So this is the NTC Temp. So this one I want, this one I want, and I guess I'll take this one, but I do not want that one, and I do not want this one. Yeah. so I can hide those. Boom. Okay, so now I can go back. I can go back into Tanks Multi, go to 1, and here's what I need. I need the tank pH level, tank 1 pH level, tank 1. I don't need this resistance value. Later on it might be coming handy though, because if this is the resistance value, no, that's just an ohm, so it doesn't have anything to do with the conductivity of the liquid, but I don't know what I'm going to do with that. I just don't have to add it to my front end. And then here is the thermistor. So that water is 70 degrees. Yeah, nice. Well, now it is, but still. Cool. So if you don't get the right temperature, just know that, you know, like you just gotta work at, you can comment all those out, recalibrate everything, and go back in. No big deal. No big deal at all. And you have to do that per thermistor too. Per thermistor. So what now? Oh yeah, I gotta put this whole hot mess together, right? Because it's just it's just a complete hot mess, and I gotta glue it all together. So right now, this is what my desk looks like. I'll zoom out. It looks like I'm making a. I'm not. So got this. This all goes into here. This is. I hope they don't demonetize me for saying the word. Nah, they won't. So this goes over here. I got these 2 ports. I'm going to tidy all this up, clean up my desk, and then I'll share with you the results in the schematic. So if anything is interesting, I'll document that along the way. Okay, so there she is, all kind of tucked in there. It's got a little hole right here so you can plug it in and add new code to it if you need to. But there is some extra stuff in this one because it was the beta, but I like it anyway. So I will show you the schematic and walk you through that here in a second. This is what it looks like. It's got all the wires that are headed out here. These are the thermistors that go to the tanks. I only got 2 thermistors for this one. I got 2 more on order. They take a long time to get here. I'm ordering 3 more of the pH ones, and they do take a long time to get here too. I would say I ordered all these parts. It probably took a month to get here from AliExpress. So when you do put your order in, if you decide to build something like this, just be patient and it will all come in the mail at once and you're all good to go. Other than that, it was a really fun build because all this stuff is super highly undocumented. You can look around the internet and try to find some stuff, but really the pH one is definitely not documented well whatsoever. The thermistors aren't too bad. The NTC in ESP Home is pretty well documented, but still I feel that, I don't know, like since the thermistor wasn't really an official thermistor with a B setting on it, I had to do some hand calibration with it. So I did get the opportunity to learn how to calibrate a NTC thermistor and show you how to do that, which was fun. But other than that, it was a great build. It was fun. So now I got to order some more weird sensors and try to find another project and add all these other ones on here once they get here. So let's go look at the schematic real quick and see how easy it looks now. Alright, so here is the schematic all in its glory, and it's a lot simpler. So all we're doing right here is we got 3 pins that are active on this sensor. You got the power, the ground, and the data coming off of it. Okay, so the data gets hooked up to a voltage divider because it has 5 volts of data coming off of it, and we have to get it to 3 volts. So what happens is you have your ground and you have your power, and then what you do is you this is 2000 ohms and 1K. So if you take a reading here, it's 1/2 of that, just about. So that's a good way to divide it down to the 3 volt range. So now that this pin has its 3 volt, you can read the data from that quite nicely. Because 0 to 5 volt will not work, but 0 to 3 volt will. So that's what that part of the circuit does. Alright, so over here we have another kind of voltage divider. This is the thermistor. Okay, it's running off resistance. And what happens is the data coming off of it is going into one side of this, and then it's going right into pin 35. Okay, so this is pin A0, or in another case it's called GPO36, but this one's 35. Okay, and then this is a 5.6K resistor. 5.6K resistor. And it is being powered by this 3.3 volts. So what I'll do is I'll clean up this, label this one. I noticed that I have to label that one. I have to kind of label these right here. But other than that, it's pretty clean. I had to make some of this part in fritzing because they didn't have that variation of it, so I had to learn how to use the Inkscape to make custom parts within fritzing. It turned out pretty good. Alright, so that is a schematic. I'll share that in the link below so you have that and you can pull it up. But other than that, I think that's it. I hope you enjoy your Electroforming Tank Buddy. I guess that's what I'm going to call it. The Tank Buddy. Nice. I like that. The Electroforming Tank Buddy. You have a good one.